Okay, I continue to be terrible at before and afters, but this is the old compartment. Well, I guess it is still a current compartment, but this is the compartment that the Onan generator was installed in, which I believe was a factory option on this Fleetwood Tioga. It was giving us problems. Well, it wasn't running when I first got it, and so I actually undertook to get it fixed. It was almost like a project or a challenge, and I did get it fixed and running. And then I accessed Onan's, which is owned by Cummins. I accessed their online technical manual for techs and bought a $24 tool and tuned the generator so it was all set up, exactly as the factory would have it. But shortly after the accident where I ripped off, the mishap where I ripped off the stairs again, the generator stopped working. So I thought it was a grounding problem, but more than that, I decided it wasn't worth it because it was an old generator and it was the Emerald 1. And as I was researching it, people were basically, they were saying, check this, check that. But more to the point is they were also adding, and if the points haven't been changed or the coil, then those will also fail on that. They gave some telltale signs where they said, the near spark plug fouls and ignites differently, sparks differently than the far spark plug on the back side of the generator. So I kind of took all of this with a grain of salt, but when I had an opportunity, started to troubleshoot it because all of a sudden the generator wouldn't start. And so we had no offshore power. We only had plugged in power and 12 volt, which we were fine, but we couldn't run, AC or microwave or anything like that. So I pulled the plugs and checked them out, and actually it was kind of a relief to find out that the front plug was fouled and the back plug was not, exactly as somebody described would happen if there's these other, pending maintenance items that needed to be done. And so it was a tough decision because I tend to get kind of, obsessed about fixing things and making it run how it's supposed to or whatever. And so I made the decision actually to just walk away from it. Because if I fixed whatever the problem was, which I hadn't diagnosed yet, then I would have these other maintenance items in the future and it would never run like a new one was supposed to. And then that was the final straws when I was researching it. The newest generator of that model, the Emerald line, burned 0.7 gallons per hour at max load of gas. So if you do the math on that, gas is about 330 or whatever, 350, 370 a gallon right now. This is January 2019, meaning that for each hour that you generate electricity, utilities, you're paying about $3, maybe $3.25. And when you start adding that up, 1 hour per day, and you've already reached probably what a small house is going to be. 2 hours per day, you're double. 3 hours per day, triple. Obviously, you do the math, but if you want, power 4 or 5 hours per day, you're paying like $20 a day in utilities times 30 days. That's like $600 in utilities, which is ridiculous. So, all of those things combined, once I realized that even buying a brand spanking new generator, if we could afford it, which we couldn't because they're like $4,000, was not going to be worth our time. And so I had a buddy with a forklift help me take it out. And this was the compartment that was left with the plan of putting a battery bank in here powered by solar, which we have one panel on the roof. It's scalable to 5 100-watt panels. We have one 100-watt panel. And also charged by the alternator, which this cable conveniently, which actually came back to start the generator. It was an electric start, so the luxury model is a huge gauge wire that runs all the way up to the front. And so it can actually use the alternator to charge this battery bank, which is pretty common with self-builds. And then here is the 110 volt feed in that goes into the circuit breaker and monitor panel on the inside of the RV. So I thought, how serendipitous. So we bought an inverter, pure sine wave, that fits just perfectly in that space and is actually big enough that it could run any of our household utilities or appliances or whatever, as well as run the AC for brief periods of time. AC is super energy hogging, and so we wouldn't want to do that because you're not supposed to discharge deep cycle batteries more than 50% if you're really trying to extend their life. And then I got a screaming deal on some deep cycle batteries that were still under warranty, but were being sold for really cheap. So they're used, but still under warranty. But I needed to figure out a way to make this strong enough to hold up several 100 pounds of deep cycle battery. So previous, it was strong enough to hold up a several 100 pound generator, but that was braced on the side, and then there's a brace here, and then a box here for some, this wiring that ran down. And so, yeah, the box steel was there to hold the generator up and keep it safe and in place. But these batteries were a lot narrower, and so they would have actually put weight on empty spaces where only this aluminum siding that I found, I scrapped. I did some scrap hunting for it, would be holding it up. Oh, and the wood planking. I'm going to make it pretty in here. So, the wood flooring. So what I did was those aforementioned stairs that I tore off. I told my wife, and I'm glad that she let me keep these, but those are the stairs. They're really thick gauge metal. They were really nice replacement stairs, just not stronger than, a several ton RV with kinetic energy, e.g. momentum, and those stairs meeting a hard object, just tore them right off. But I kept the actual stairs, cut them to size, overlapped them a little bit, drilled holes through the existing box steel, as you can see, and then secured them. So, as you can see, it's secured once on that side and twice on this side. And once I had that built, well, not once. I had it planned out before I started. So that was the plan. And then the plan next was to find some type of sheet metal to put on top of those to protect the batteries and the inverter, especially from road debris coming up. It wasn't as important for the generator because it has an air filter and it needed to breathe anyways out the exhaust. But really important for the batteries and for the inverter to be protected from the road elements popping up, especially the inverter. And so I went and scavenged this aluminum siding off my aunt's farm, which they just grow corn and wheat on now. She's older, so it's not, I guess, fully functioning. It used to be a dairy farm, I guess I should say, to be more brief than I typically am. My wife says that I'm quite verbose, as you're probably gathering from this video, if you've made it this far. So, I salvaged the scrap metal, and then I also salvaged these waterproof flooring pieces from the same farm, which was scrap remnants from when my older brother, who lives next to my aunt's farm somewhat, redid their flooring in their house, and so I had permission to take all of it. And so I put this sheet metal down, and then what you see here under these bubbles is these self-tapping screws that are made for a gauge steel, as you can see, maybe, so it's metal to metal 20 to 5 gauge. And so those stairs are not 5 gauge, they're probably 12, maybe 10 gauge steel. And this is, aluminum siding, so I don't even know if that would be 28 gauge or something. So I had no problem tapping through and securing it. And then Also tapped into the wall with smaller tapping, just plain screws, because it didn't need to hold, it just needed to hold up against the wall. So did that and then sealed it all in to make it waterproof. And then I'm just starting to install these wood planks. And then I will put the batteries in, secure them, and we'll provide an update probably in another video. So I'll call this version 1 or something like that. All right.